Hello, welcome back to my YouTube channel, and today we are going to see how you can run privateGPT on Google Colab for free. So privateGPT is this tool that allows you to chat with documents, be it in the form of PDFs, Word, or even text files. Now, usually when you chat with an LLM model, you are restricted with what you basically prompt. But with privateGPT or similar ways, you can basically give your LLM model additional context. So, for example, if you have a document or a text file that talks about something very specific, or a research paper, for example, you can take that document and using something like privateGPT create a sort of database which serves as a context for your large language model. And basically it allows you to ask specific questions pertaining to that document, and it allows you to do useful things such as summarizing and asking very specific questions to the LLM. So today we are going to see how to run privateGPT on Colab for free. Now you could do this on your local PC as well, and if you have a graphics card that has sufficient VRAM of maybe about 12 gigabytes or so, you can run a decent 13 billion parameter model, and you just need a basic graphics card like a 3060 or something to run this quite fast. But if you just want to try it out, the Colab way works really well. So this is the main repository of privateGPT. You can go to this link, give them a star. I have basically made a fork which with very minimum changes, so that you can run it directly on Colab for free. So I have created this Colab notebook, which I will link in the description. It's nothing big, it's just basic stuff that clones the repository, installs dependencies and stuff, and downloads your model, your LLM, and then straight away use it to chat with your PDF or document or whatever. So before we actually run this, let's just talk about the changes I made to this source repo, so that you do not have to worry about me doing something malicious or something. So I have renamed this environment file and made some changes so that you can run it straight away. And as you can see, we are going to use the GPU of our Colab service, which is basically good enough. It's actually a T4, which is slightly slower than a 3060, but for the most part it does really well. But the most important thing is that you have sufficient VRAM of 15 gigabytes, which is more than enough to run this model here, which is the Llama 2 GGML 4-bit quantized version, which is from the Hugging Face repo by the blog. Alright, so anyway, I have just changed this environment file to basically use the model that we are running. And I have found out that the 13 billion model and the 4-bit quantization is far better than a 7 billion model, which seems to quite drastically hallucinate, which means that it does not interpret or does not understand the context of the supplied documents that much. But this 13 billion model works way better than the 7 billion model that I tried. So maybe it's because I used an even lower quantization. I do not know. I don't remember, but I generally think that the 13 billion model works way better. So well, that's a change, first change I made, and then I have modified these ingest and private GPT Python files. So basically, you use the ingest py to load or basically convert your source documents into these sort of database files. So it's actually, if I remember correctly, called as vectors, and that eventually becomes the context. So your entire documents becomes the context by running ingest py, and once you have done that, you can perform inference using privateGPT.py. So I think I have hard-coded the source documents directly where you will place your PDFs or words or whatever. For some reason, it did not load it correctly from the environment file, or for some reason it did not pick up the PDFs that I uploaded to Google Colab's temporary storage. So I just hard-coded this directory right into it. And the other change I made was to use the actual GPU. Now, it was only until recently that Llama CPP Python got GPU support. So to use that, because your model, the Llama to GGML model, it actually can run on both CPU as well as GPU. But the basic model, the default model that comes with private GPT is, if I believe correctly, it's this one, and it does not run on GPU. So it is not compatible with Llama CPP. Therefore, you'll have to find another GGML model. So this model works with your GPU, but to enable that, you will have to change the model type to Llama CPP. By default, it's in GPT for all. You'll have to change that to Llama CPP for your model to actually, for your compatible model to actually be using your GPU. So once you have set that in the environment file, the model type as Llama CPP, you'll also need to call the Llama CPP function with these extra arguments. The NGPU layers actually offloads the model layers to your GPU so that it utilizes the VRAM of your GPU. And the context size, by default, it's if I recall correctly, set to 512, and you will I don't know if it was just specific to me, but I got errors of running out of context size when it was just 512. So setting that to 2048 ensure that you never run out of the context window. So yeah, so that's the changes that I made to these to the repo, which if you can do it yourself, you can fork it yourself and do it on your own. Also, I think I made this models directory so that you don't have to do that in the Colab. All right, so that's the basic things which are which this fork is different from private GPT. All right, so let's just straight away go and run this on Google Colab. So first of all, let's just connect to our runtime, and once it's done, you can check that your notebook is actually using your GPU by running the NVIDIA SMI command. So as you can see, we are connected to the runtime, and let's just check if we actually have it showing our GPU, and it does. All right. So once that's done, let's just install the repo and dependencies. It's going to take some time, and you'll have to sit and wait till this gets finished. As you can see, once we are cloning the main repo, we are installing its requirements. Also, for some reason, it did not install the sentence transformers library. That's why I'm installing it separately. To download your models, you'll have to install the Hugging Face Python library, which is from where we are downloading our models. So that's why we are installing Hugging Face. And we are installing the latest Llama CPP Python because that's the one which has GPU support. So we are going to install it with these flags so that we are actually building it and installing the latest version which has the GPU support. So it's going to take a while. Let's just wait for it to complete. Right, so as you can see, we have successfully installed all the dependencies and the extra packages. Now we need to restart our runtime because some of the packages, the new ones, to use them, we'll have to restart your runtime. So we will do that. All right, so we have restarted our runtime and we are good to go. Next thing is to download the model. As we said before, we are going to use the Llama 2 13 billion 4-bit quantized model. You can actually go to their Hugging Face repository, and they have a list. They have actually a table of all the different models, the different variants with the different quantizations of the Llama 2 GDML model. And you have in that table you have all the requirements, the VRAM requirements. So the 4-bit quantized _1 version, I think it requires almost 10 gigabytes of VRAM. Of course, I think the the Q5 version actually takes something like 12 gigs of VRAM. So you can theoretically run that in Google Colab with the same GPU, as well. But I think this is good enough. Maybe if you want, you can experiment with that as well. So we'll just go and download this model. So usually it's fast, but sometimes it might be throttling depending on the time of the day you are doing it. If it's on rush hour, I have, sometimes it has gone as slow as 1 megabytes per second, but usually it's fast. If it's extremely slow, maybe stop it and try it again. So while that's happening, we will just talk about uploading our documents uh, to our temporary storage for ingestion. So to do that, you'll have to place all your documents in this folder called as source documents. Right now it's empty because there's nothing in there. So ideally, I would say if you are uploading something like PDFs, make sure that it's not very large, or if it's very large, use something like PDF to text conversion so that you are actually uploading a text file. The reason is that the model might not interpret all the images and tables in your PDF that well, but when you have it in text, it's just the textual data that the model has to work on, which in my opinion works better than when you have a PDF. And sometimes the Colab also does not upload PDFs of very large size. It doesn't allow you to do that for some reason. But anyway, I have a PDF of this paper here, which we will convert to text and then upload it to this document, this folder over here, so that we can ingest this. So let's just type in PDF to text. Use something like, it doesn't matter which website you choose, so long as it works. All right, so I didn't all right, so let's just convert it. All right, so we have our text file and our models downloaded. So let's just upload our document. All right, so our document's uploaded. So let's just check that our document is fine. So yes, so it's the text is well preserved, and it does not have all of those tables and images. So of course the equations and stuff are kind of messed up, but anyway, we are not going to get much information about the finer details of mathematics or equations with this anyway. So the text seems to be well preserved, and that's all that matters, at least for now. All right, so once we have uploaded our source files, we can ingest it so that it converts it into the vector files, which serves as context to your model. Let's just run this the cell, and once it's done, you should see a folder named db, which stands for database, and it will have all your database files. So as you can see, it's creating the embeddings. So if you don't see this this progress bar, it means that it hasn't been able to access your files inside your source documents folder. So you should make sure that your file is inside this in this folder, and it's it's properly readable and stuff. So as you can see, once it's finished, it created this db folder, which when you run your Python file, the privateGPT.py, which is where you actually chat with the model with your database as context. As you can see, you'll have these files and the index files which serve as the context for your model. So let's straight away go and chat with our PDF. So as you can see, it has detected our GPU model, GPU, and it shows the compute capability as 7.5, which is in fact slightly lower than a 3060. If I recall correctly, it's something like 8.6 with a 3060, but it's not bad in any way. It's more than enough to run this model. So you should wait till you see the enter query prompt. Once you have once it shows enter query, you can enter whatever questions you want to ask to your model. So as you can see, it's taking about 8 gigabits of VRAM. So looking back, maybe you could use a higher quantization, but I'm not sure about how that would really perform. I haven't tried that, but it's something that you could always check. But either way, a 7 billion model with a very low quantization is not that good. So keep that in mind. And as you can see, we have the enter query, and let's just ask it something basic like, what is this document about? So the average time it takes for a query is about 1 minute. So yeah, it's a bit slow, but you're doing all this for free anyway. So let's wait till it gives us an answer, hopefully. So all right, so the document, so this is something that you'll run often, but as you can see, it already has this context set. So we need to uh, really tell the model about which document we are talking about in order to help it understand that we are actually talking about the paper. So maybe we'll just ask something more specific, but as you can see, it is it does know that it's a scientific article, and the title, volume, and issue number are provided, but there's no abstract. But let's ask it something even more specific. So like, let's say, so we know that it is a scientific paper about a certain topic, let's keep that topic, refer to that topic in the prompt as well, and specify that we are actually talking about this document. Uh, and then specify our question uh, in an even more narrow fashion. So let's ask something like, so let's ask it a very specific question that's specific to this paper, and let's see how it answers to that. All right. So previous answers took 70 seconds, so basically a minute and 10 seconds. So that seems to be the average time it takes to give us an answer. And maybe you can even reduce the context size a bit, but I honestly don't think that helps uh, fasten or sort of increase the speed of the generation anyway. But you can, so the total number of layers that this model has is about 43. So I have offloaded just 40 layers, which as you can see here is the parameter that specifies how many layers you want to be in your GPU's VRAM. So maybe you could even set that to complete the full 43 layers itself, because why not? All right, so it seems like it has just given something. So so let's see, as per the paper's context. So yes, it has it actually gave the correct answer regarding the mechanism, and it also says that the mechanism is influenced by the thickness and various other parameters like temperature. Uh, so it seems to be doing well when you actually specify what document, when you explicitly specify the document that is to be used as context. And let's even ask it, let's ask it about who it thinks the authors of the paper are. Let's say if it comes up with it is not a hard question to answer, but let's say if it can do that, can it basically tell from the text who the authors are. So I'll just copy this part of the prompt and ask it who the authors of the paper are. It might seem very trivial, but uh, when you think about it, all you are giving it is this text file, which is not properly formatted. It does not have the information that, you know, like we can immediately see who the authors are by just looking at it. But that's not the case for the paper, at least. For the AI, at least. Let's see. All right. It says the authors of the research paper are not mentioned in the given context. Um, okay. Let's let's ask it again. Let's ask it again. I have had times when it worked, when the paper is not as big, so the size of the document matters, and also your model matters. If it is a 7 billion parameter model, it usually has a problem with hallucination. It kind of has a hard time understanding the context given to it, and all right, so it does not know what the authors are, and honestly, I don't think that's a problem, because it simply uh, might not be able to parse that information exactly. So maybe let's not be worried about that. Let's ask something even more specific, like let's ask something specific that it hopefully can get out of the document that we supplied. So if you check the GPU RAM, it's almost speaking around a little over 10 gigs, which is exactly what, if I recall correctly, what the Hugging Face repo specified. Okay, so this is the answer that it gave. Let's check if that's I'm not exactly sure if this is correct. I don't think it's correct, because we are asking about a usual material that's three-dimensional, and as the temperature decreases, the resistivity usually goes down, and at very low temperature it goes down even faster. So I'm not exactly sure whether that's correct. Okay, what does it tell here? However, as the temperature increases, the resistivity decreases. Alright, so it's not exactly clear at what temperature ranges. It is not specifying at which temperature ranges these decreases and increases are happening, because that's important. And it's not specifying that. Maybe there's a threshold at very low temperatures, after which it starts increasing again, but unless that's specified, it does not make sense. All right, so it's not very clear. At first, it says it's increasing with at lower temperature the resistivity is high. Yeah, this statement is not factually correct. So so you have to be wary when you actually use it for very specific questions, and I think it's not doing it fair to ask questions about something that's specific and something that is a research document, because it simply is not able to grasp these scientific concepts, these logical concepts, especially these concepts that are quite large and are basically many different concepts intertwined. So it simply might not be able to have a coherent understanding of all of those concepts required to answer these specific questions. But if you are writing an essay or something, or need a fiction summarized or something like that, a story to be summarized, this would be more than enough to do just that, because there's not logical or these sort of concepts, these hard concepts needed to summarize or extract relevant information out of stories or books, for example. So that's it, and you can play with different models, maybe change the GPU layer, maybe try something even bigger. For example, you could even try a 6-bit quantized model, because apparently you have some more VRAM that you can use. So hopefully, if you can use a higher quantized model, maybe the quality of answers will definitely increase. Also, I haven't tested multiple context sizes, source documents. Apparently, you can add more documents to this folder, and you can ask questions from all of them. But I'm not very optimistic about doing that, because you have a fixed context size, and maybe adding more would not help. Maybe it does, who knows. So that's it for this video. Once you have done that, you can stop your Python file, and you can save it, save the notebook, save a copy in your drive, so that you do not have to access it through the link all the time. And you can experiment more, and once you have done that, maybe you can test it on your local machine as well. So that's it for this video. If you have liked it, please let me know in the comments. If it's possible, like, share, and subscribe. Thanks.